All right, folks, it's back in action here. In this video, we are going to take everything from the foundations of the unit circle video and put it together and actually create the full unit circle. It's important that when you are working with your unit circle and you're trying to learn it, to not try to memorize things all the way around. I've broken this down into pieces, and I strongly encourage you to think about it always in terms of these pieces, because trying to do a hardcore memorization all the way around is going to make this way more difficult than it needs to be. So the first thing that I want you to notice, and I've colored mine, you can pause and color yours as well. First thing that I wanted you to notice is I've taken those lines from those previous that previous video, and I've connected them here so that you can kind of see how all these are coming together. So what we're going to do first is we're going to first understand our angles all the way around the circle, and we're again going to do them in bits. So I'm going to start here at our smallest angle, and from the previous video we should understand that this smallest angle here is 30 degrees. Now let's mark this in terms of degrees and radians. Again, thinking one less and one more. If each of these little angles here are 30, we know in terms of degrees, this is 180 and 360. I'm going to go 30 degrees less, 30 degrees more, 30 degrees less, which is going to make my other angles, it's going to make this angle 150 degrees. It's going to make this angle here 210 degrees, and this angle over here 330 degrees. Now, 30 degrees in terms of radians is pi over 6. So that's going to be pi over 6. And if we're going to, again, think 6 pi over 6 and 12 pi over 6, we're going to go less, more, less. So that's going to allow us to easily fill in our 5 pi over 6, our 7 pi over 6, and our 11 pi over 6. If you have not watched that foundations video, you need to go watch that first. Otherwise, these numbers are going to feel pretty random. The next thing we're going to look at is going to be our next spot, okay, and that's going to be right here at 45 degrees. So this is going to be 45 degrees. We're going to do degrees first. We're going to go 45 degrees less, more, and less, and that's going to give us our 135 degrees right here in our second quadrant. It's going to give us 225 degrees in our third quadrant and 315 degrees in our last quadrant. 45 degrees in terms of radians is pi over 4. So now we're going to go 1 pi over 4 less, more, and less, remembering this is 4 pi over 4 and 8 pi over 4. So that's going to give us a 3 pi over 4, a 5 pi over 4, and a 7 pi over 4. These are just coming from that other video. The last one we're going to look at is going to be this angle up here. That's going to be our 60-degree angle. So that's going to give us 60 degrees. In terms of degrees, the next quadrant then will be 120 degrees. The next quadrant then will be 240 degrees. And our last quadrant is going to be 300 degrees. Now, 60 degrees in terms of radians is pi over 3. So we're thinking 3 pi over 3, 6 pi over 3, and 1 less, 1 more, and 1 less. So that gives us a 2 pi over 3, a 4 pi over 3, and a 5 pi over 3. If you always think of them in terms of those little pieces, it's going to make it a lot easier for you. Now, the next thing that we can do also in terms of our angles is we can recognize that this is going to be 0 degrees, 90 degrees, 180 degrees, 270 degrees, didn't quite close that there, and then also 360 degrees. We've talked about coterminal angles. 0 degrees and 360 degrees are the same thing. Now, in terms of radians, this would also be 0 radians. This would be our pi over 2. This is going to be our pi. We'll have our 3 pi over 2 down here. And we'll have our 2 pi over here. Now that's a lot of ways to think of this last spot, and that can get confusing. So that's something to really pay attention to. Now, what we're going to do is we're going to start adding in our ordered pairs. Since this is a unit circle, this ordered pair over here at the far right is going to be over 1 unit and up 0. Up here at the top, we're going to have the ordered pair 0, 1. Over here on the left, didn't get that ordered pair there. Over here on the left is going to be a negative 1, 0. And at the bottom, we're going to have a 0, negative 1. Now we can pull in those ordered pairs from the previous video. What we need to visualize is that nice right triangle that we did over in the other video and where we created the 1 unit radius, and that makes this first ordered pair at pi over 6. This makes this a radical 3 over 2, comma 1/2. The pi over 4, it's going to be our radical 2 over 2 and our radical 2 over 2. Since it's a 45, 45, 90, those will be the same. And then at 60 degrees, it's this ordered pair, but just reversed. So now it's going to be a 1/2 and a radical 3 over 2. Now, what I am not going to do, and what you'll see in many versions of the unit circle, is I'm not going to rewrite the ordered pairs all the way around. What we want to understand is that these two ordered pairs at, let's say, the pi over 6 and the 5 pi over 6, 7 pi over 6 and 11 pi over 6, are always going to be these same numbers. The only thing that's going to change is whether they are positive or negative. So we're not going to rewrite them all the way around. What we instead want to understand is that in the first quadrant, both coordinates are positive. When we get over here into the second quadrant, those coordinates are going to change, and the x coordinate's going to become negative and the y coordinate's going to stay positive. In the third quadrant, they will both become negative. And in the fourth quadrant, we'll have a positive and a negative. If you remember this in terms of their signs, it's much easier because now instead of trying to memorize ordered pairs all the way around, you're only working with this first quadrant. And then these signs are going to allow us to utilize everything else that we need to do with the unit circle. Now what we want to understand is, why are these numbers even useful to us? So let's go to the bottom section of this, and we're going to look at how these numbers become useful. Now, we're going to go back to our good old Pythagorean theorem. We're going to love that, of course. And we're going to look at this circle here, and I'm going to say this is an x-coordinate, this is a y-coordinate to create this nice ordered pair on a circle. Okay, for right now, I'm just going to call the radius r. We're going to pretend that it's not yet a unit circle. It's just a general circle. If we apply our equation for the Pythagorean theorem, what we're going to see is that we have an x squared plus a y squared equals an r squared for this right triangle, but this is also the equation for a circle. Because if you recall from your geometry days, the equation for a circle and the equation for the Pythagorean theorem are the same thing. Now, if we look at this little triangle that we've got going on here, just looking at our right triangle that we just did our Pythagorean theorem on, and we think of this angle right here as theta, we're going to find the sine of this angle. So we're going to stand here at origin, and sine, of course, would be opposite over hypotenuse. So that would be our y over r. The cosine then would be the adjacent over the hypotenuse, and that's going to be an x over an r. And our tangent would be our opposite over our adjacent, or our y over our x. Of course, we can fill in all these reciprocals down here. Cosecant will be the reciprocal of sine, so it's just going to be r over y. Secant's going to be the reciprocal of our cosine. That's going to become our r over x, and our cotangent will be the reciprocal of tangent, so it will become x over y. Now, we've got these nice little ratios here, and these can be useful, but they are most useful for us if we understand and think about this as a unit circle. So if our radius becomes, in fact, 1 unit, then our denominator here just becomes 1. So on a unit circle, the sine of theta becomes y. And on a unit circle, the cosine of theta becomes x. Tangent, of course, is still going to stay y over x. Now, how that's going to be useful is if we come back up here to the top, understanding that sine of theta should be y, then what we're going to learn is that the sine of pi over 6 or of 30 degrees, the sine of theta is 1/2. So if you pause this video and type into your calculator sine 30 degrees, you will get a perfect 0.5. Okay, that is how we are going to utilize our unit circle. The y coordinate on the unit circle will represent the sine of whatever angle you're looking at. The x coordinate then on any point of the unit circle will represent the cosine of whatever angle you're looking at. That's why when we're going around the unit circle, if we just understand whether it's positive or negative, we will be able to find any value. So for example, over here at 5 pi over 6 or 150 degrees, sine is still the y coordinate and will still be 0.5. Again, pause your calculator, type sine 150 and you'll still have a positive 0.5. But if you type sine 210, you're now going to get a negative 0.5. Furthermore, sine 330 will also get you a negative because sine will be positive, positive will become negative here and negative here, but the number itself stays the same in all four quadrants when the angle, the reference angle, is the same. The same could be said for cosine theta, but of course we don't know radical 3 over 2. The last thing we're going to look at is we want to understand how tangent works on this, because since tangent involves both of these ordered pairs, we're going to come down here to the bottom and we're going to calculate our tangent values. So tangent of pi over 6 should be then our x coordinate, our y coordinate over our x coordinate. Well, the y coordinate at pi over 6 is going to be 1/2. That's going to be divided by, notice I'm not writing fraction and fraction, that's going to be divided by the x coordinate, that's going to be a radical 3 over 2. Now we can work with this in a simpler way. So 1/2 times this reciprocal. That's going to, of course, tell us that these halves are going to cancel. That's going to give us a 1 over a radical 3. And if we rationalize that, would give us radical 3 over 3. We can also do the tangent of pi over 3. The y coordinate at pi over 3 is going to be radical 3 over 2. Again, we can flip back up here and see that. We're going to do a radical 3 over 2 divided by 1/2. Radical 3 over 2 divided by 1/2 is the same as multiplying by 2. So we're going to cancel these. So the tangent of pi over 3 is a radical 3. Now, I like to, and this is just a personal preference, I like to come up here and I like to write those tangent values into my unit circle up here. So I kind of usually write them off like in a little bubble. So the tangent of 30 degrees, we found it out down below, was a radical 3 over 3. I like to put it in a little bubble here, and we can even label it tangent theta. The tangent of pi over 3, again, we calculated it down below, was just a radical 3. I like to put it in a little bubble. Tangent of pi over 4, well, these values are the same. So radical 2 over 2 divided by radical 2 over 2 is just 1. Now, quick little note here. The tangent at 0 is going to be 0 divided by 1, and that is going to be 0. Notice there's a lot of zeros happening here. You can also think of that as the slope of the x-axis. Y over x is rise over run, so the slope of the x-axis is 0. That would mean that when we get up here, the slope of the y-axis should be undefined. And sure enough, 1 divided by 0 is going to give you an undefined value for tangent. So if you want to write that down, that's kind of a nice little reminder that tangent is undefined at pi over 2. Okay, that is our unit circle. Spend some time just thinking about how can you practice those angles? How can you remember that these are the ordered pairs for the first quadrant and these are the tangent values? And then in class, we will practice this a whole lot more.